Yes, let's start. So we know this method, reduction of order, to get the other solution if our characteristic equation has repeated roots. It's okay. So let's give some example. And here we have some example and answer here. And first of all, solve this initial value problem and the solution here. It's okay. So another one, and the y sub 1 is the solution of the, and this one, it's okay. So, and this one is homogeneous, second order differential equation, but not constant coefficients, not constant coefficients. So we don't know how to solve, but here question, and the y sub 1 is the solution of this differential equation. So what is the y sub 2? And so how to find this one? Using the reduction of order. It's okay, reduction of order. So we obtain this one. So if we know the y sub 2 and y sub 1, so it is easy to write the general solution. It's okay. And here, find the y sub 2 only by using the reduction of order. It's okay. So let's more examples here. It's okay. Yeah. Homeworks, it's okay, and they choose some of them. Let's solve and some problem. It's okay. First of all, let's solve this one, this question. It's okay, not homework. It's okay. Solve the initial value problem. It's okay, initial value problem. So write the characteristic equation, the corresponding characteristic equation. So this one, and use the formula to get solution. So 2 over 3 double root and multiplicity 2. It's okay. Repeated root. So and we know how to write the solution. Solution is y sub 1 e to the r1t y sub 1, and y sub 2 is repeated root t times y sub 1 and t times e to the r1t. So we obtain y sub 1 e to the 2 over 3t, y sub 2 this one. So what's the general solution? General solution c1 y sub 1 and c2 y sub 2. Yes, this one is the general solution. But this one is initial value problem. So, and using the initial condition to get unique solution of initial value problem. It's okay. So, and our aim is to find and C1 and C2 here. It's okay. Use this initial condition and this one. If y is this one, it's okay. So what's the y0 first condition? Y0 should be 2. And substitute here, t is 0, t is 0. It's okay. So we obtain e to the 0 is 1. This one is 1. We obtain and also t is 0 here. So we obtain only c1. c1 is 2. Yes. And the next initial condition, y prime 0 is minus 2. Use this one. If y is this one, it's okay. So and use this initial condition, you have to compute the y prime and take this one using the product rule, and the derivative of the first one 0 plus 1 c2, this one, times second one, this one. So first one, yes, times derivative of the second one, derivative of the e to the 2 over 3t, and we obtain this one. So and substitute here, t is 0, y prime is minus 2. It's okay. So we obtain the value of c2. c2, this one, c1 is 2. So, and write here in general solution. It's okay. General solution. And then we obtain unique solution. If c1 is 2, c2 is this one. So we obtain unique solution of initial value problem. Any question here? Okay. So let's give one more example. It's okay. One more example. T minus 1 y prime, y double prime, minus t y prime, y is 0, t greater than 1. It's okay. This differential equation has y sub 1 e to the t as a solution. It's okay. So, and the question here, find the second question here, find the second independent solution of the differential equation. We have our differential equation and we have only one and the solution, but this one is second order differential equation. Question, find the second independent solution of this differential equation. So what is the y sub 2? It's okay. And here, using this and the hint, and by reduction of order, using the reduction of order, we obtain y sub 2 is t. Another method, by using this method, example and so on. What's this method? We claim that this one is the formula, and to find the y sub 2. Y sub 2 over y sub 1 prime is equal w y sub 1 square, and the w here Wronski indeterminate. It's okay, Wronski indeterminate. And if we know the Wronski indeterminate and y sub 1 and this one, so it is easy to get the y sub 2 here. It's okay, and using the Abel's formula. It's okay, to second independent solution of differential equation. And here, let's consider this and the question and find the y sub 2 by using the reduction of order, first method, and the second one using this method and also Abel's formula and this formula, and we obtain the same result. Y sub 2 is t. It's okay. Let's see this one. But here, so and the second method, using the method of example, special example, and this one. So what's this example? Let's give this example. It is important. It's okay. This one. So, and the page number and question this one. For a second order differential equation, variable coefficients. It's okay. Variable coefficients and means not constant coefficients. It's okay. So, and look at this one, second order differential equation, homogeneous, but look at the coefficient of y prime y and y double prime, it's okay, is not constant. So, we don't know how to solve this differential equation, it's okay, and characteristic equation not valid here because not constant coefficients. So, here, y sub and take this and the differential equation. If y sub 1 is a solution, it's okay. Then second solution, have to find second solution. If we know y sub 1, have to find y sub 2. If our differential equation this one for second order and also not constant coefficients variable. It's okay. So and satisfy this formula y sub 2 over y sub 1 Wronski indeterminate y sub 1 square, and here Wronski in W is okay, and then use the Abel's formula to determine y sub 2. It's okay. And what's the y sub 2 and Abel's formula? Abel's formula, this one we know in the previous lecture. W is C e to the minus pt dt. What's the p? Pt here. Look at our differential equation. Write the standard form. Standard form means and the coefficient of y double prime is 1 and the coefficient of y prime gives p of t. It's okay? P of t. Any question? And be careful, and our differential equation should be standard form. Coefficient of y double prime should be 1 and the coefficient of y prime is p of t. It's okay. So, and we know and I have to compute the Wronski determinant is the determinant of this one. W y sub 1 y sub 2 is equal y sub 1 y sub 2 y sub 1 prime y sub 2 prime. But if we don't know and y sub 2 is okay. And so, using the Abel's formula to compute the Wronskian. This one is the definition of the Wronskian, and And also we know and the Abel's formula, compute the and this one. And if we know this our differential equation in this standard form and catch the and the coefficient of y prime p of t, using the p of t, it is easy to compute the Wronskian. It's okay here. Yes. Let's come back our question. It's okay. And in a solution of the our question, use and this and the formula and Abel's formula to get the second solution. It's okay of our differential equation. This one. It's okay. Yes. Now let's find the second fundamental solution using the previous example. Use this formula and Abel's formula. It's okay. And so, first of all, you have to write this. Write our differential equation in the standard form, because our differential equation not standard form. The coefficient of y double prime t minus 1, not 1. It's okay. Write the standard form. So, and standard form this one. Multiply 1 over t minus 1. We obtain the coefficient of y prime is 1. Y double prime is 1. Yes, standard form. And then standard form, what's the p of t? Yes, p of t coefficient of y prime. P of t is equal minus t over t minus 1. So, and let's compute the Abel's formula. It's okay. What's the Abel's formula? And c times e to the minus p of t dt. Write the p of t here. So we obtain the integral and compute this integral. How to compute? And the separate parts. It's okay. This one is rewrite 1 plus 1 over t minus 1. And so this one is integral, and the 1 gives t, and the integral of 1 over t minus 1 and the ln t minus 1. It's okay. So, and so right, and this one is this one. What's this one? E to the ln a. E to the ln a is equal a. Use this one. So we obtain t minus 1 here. So Wronskian this one. It's okay. Wronskian this one. And then using the and the our formula. What's the formula? The other formula. And this one. It's okay. Let's write this one. And to find the second solution of y sub 2. It's okay. And so second solution satisfy this one, because and to find the second solution, we claim that and the second solution satisfy these differential equation. It's okay. Use this one y sub 2 satisfy, and write the Wronskian determinant here. Wronskian determinant this one, substitute, and also we know that y sub 1 here. Let's come back. Y sub 1 is e to the t, right? And write the y sub 1 here and Wronskian determinant, and also here substitute, and then this differential equation will be and this one. This one is okay. So we obtain this one. So our aim is to find the y sub 2. How to find? And integrating both sides is okay, because derivative here, and then we obtain, it's okay, we obtain y sub 2 e to the t, and this one is equal, c is a constant, c times this one. It's okay. So this product, and so using the integration by parts, of course, and the polynomial times exponential, of course polynomial should be u, and this one is dv. It's okay. This one is dv. This one is polynomial u, should be u, and the other parts dv. It's okay. Using the integration by parts, and then so u is t minus 1. What's the du? Du is dt. dv is this one. Integrating both sides, we obtain v. v is e to the minus, minus e to the minus t. And then using the and the y, this one is equal c times e to the t, and write integration by parts formula. U times dv is okay, is uv minus v times du. Use this formula, and u times v is okay, this one, u times v, and this one gives v times and minus v times this one plus, it's okay. So, and rewrite this one. So we obtain y sub 2, this one. C is a constant, and also C times C2 constant. This product is constant, is denoted by C2, is both C2 maybe. It's okay. So we obtain y sub 2, this one. It's okay. And then here in the question, what's the question? Our question, show that or find that the second differential equation and by reduction of order y sub 2 is t here. Let's come back here. What's the solution of y sub 2? We claim that y sub 2 should be this one. C1 and C2 and a constant. So, and take the, for example, we obtain infinitely many solutions, but choose one of them. It is enough. It's okay. So take, and the C2 is 0, C1 is 1. So we obtain solution. It's okay. And we are done. So what is the and the sorry, and take the C1 is 1, C2 is 0. What is the reason to get y sub 2? Because our aim is the second independent solution. It's okay. Y sub 2 does not contain y sub 1 because y sub 1 is e to the t. It's okay. But here y sub 2. It's okay. We can ignore this one because and the general solution and the y sub 1 and y sub 2 fundamental, y sub 1 and also here, it is enough to take this one, y sub 1. It's okay. And so take the C1 is 1, and so we obtain y sub 2. It's okay. Because and this part coming from the y sub 1. It's okay. Yes. Any question? So it is enough take this part because this part is coming from the y sub 1. It's okay. Any question? But this one is the first method. It's okay. Let's come back our question. Find the second independent solution using this problem. It's okay. This one and Abel's formula. And the second method, find the second independent solution using the by reduction of order. Reduction of order. It's okay. Reduction of order by using the reduction of order to get the second independent solution. Okay, let's apply this method now. What's the reduction of order? Reduction of order, we know that if we have the y sub 1, it's okay. If we know, and what is the reduction of order? Y sub 2 is v times y sub 1. It's okay, y sub 1. We have and the y sub 1. What's the and another one, another solution? V times y sub 1 and this one is a solution. Our aim is to get the what's the v here? It's okay, v. V is a function of t here. It's okay. V is a function of t. Our aim is to find the v. So And if this one is a solution, this one is a solution. What does it mean? Solution of the differential equation means satisfy our differential equation. It's okay. So what's our differential equation? Our differential equation this one. It's okay. So satisfy our differential equation means write here y sub 2, y sub 2, y sub 2 should be 0. It's okay. This one should be 0 because y sub 2, if y sub 2 is a solution. So, and our aim is to find the v here. It's okay. Y sub 2, this one. It's okay. This one. And our aim is to get the y is v times e to the t. Our aim is to find v. And this one is a solution and satisfy. So you have to compute double prime and prime. So y is this one. What is the y prime? Y prime and derivative with respect to t, and this one is product first one times second one, and the derivative of the first one times second one, and the first one times derivative of the second one, e to the t, derivative e to the t. It's okay. So we obtain this one. And then compute the second derivative. It's okay. Double prime, y double prime with respect to t, derivative with respect to t, and this one is product. I think it will be better rewrite to apply this one, because otherwise compute the derivative of this product and then compute the derivative of this product. But rewrite, we obtain only one product. It's okay. So, and it will be better take the right side to compute the y double prime. It's okay. So y double prime, yes, and use the product rule, derivative of the first one, v double prime v prime times second one, and first one times derivative of the second one, e to the t, e to the t. So, and rewrite this one. So, and e to the t and a common factor is okay. So we obtain this one. So, and y sub 2, we claim that, and the y sub 2 is a solution. So solution and means, and satisfy our differential equation, and substitute y prime and y double prime here. It's okay, our differential equation, right? Double prime this one, t times y prime, yes, and y. It's okay, is 0 should be. So, and rewrite this one. So we obtain this one. So v double prime coefficient this one, v prime coefficient of v prime this one is 0. So look at this differential equation. Coefficient of v is 0. V is 0. So, and yes, and use this substitution, v prime is w here, v prime. So this one is w, this one is w prime. Use this substitution. So, and we obtain this one. It's okay. And here, and also let's come back our question. Consider this differential equation t greater than 1. T greater than 1. It's okay. Be careful. And then let's come back. And the right, and we know that, and this one, but and also we know that t greater than 1. It's okay. So, and take this one. What does it mean, this one? This one means e to the t, e to the t, e to the t, not non-zero, always t greater than 1. So, and this one is, this equation means t minus 1, w1, w prime, t minus 2, w is 0. Because and e to the t times, and this one is 0, but and this e to the t not 0, so this part should be 0. It's okay. So, and we obtain the next line. It's okay, this one. So we obtain this one. So what can you say about this one? First order differential equation, because highest derivative and 1. First order differential equation, and also separable equation. We know how to solve this one because separable equation, separate parts. It's okay. So, and the rewrite and this one, v double prime over, not v double, not v double prime, sorry, w prime over w, and the solve for it is so, and we obtain this one is separable equation. So, and integrating both sides, so we obtain, yes, this one and this one, and this one means, so we obtain dw over w. It's okay because, and the w1 dw over dt. It's okay, dw over dt, and rewrite, and then so we obtain this one, this part ln w, this one means and the minus t, and this one integral 1 over t minus 1 ln t minus 1, and then we obtain and rewrite ln and ln, and so ln w minus ln t minus 1, and means ln a minus ln b is ln a over b. This one, use this one, is okay. So we obtain minus t. So ln this one is minus t means, and this one is e to the this one. Ln a is b, and so a is e to the b. That's okay. This one. Use this one, and then we obtain and solve for, and the w is this one, because our aim and solve this differential equation, and means find the w. It's okay. Yes, let's find the w is this one, but our equation not in this one transfer our equation this one. Our aim is to find the, and the v. It's okay. Our aim is to find v. And what's the v? How to find v? If we know w, v prime w. V prime w. If w is this one and the v prime is w, so right here, so how to find v here? Integrating both sides, so we obtain this one. Integral of the product, and using the integration by parts, and also it's okay. So exponential function and polynomial, so polynomial should be u and the other one should be dv. It's okay. U is t minus 1, du is dt. Integrating both sides, we obtain v is e to the minus minus e to the minus t. Using the integration by parts, we obtain v. So, and v is this one. So, and our solution is y is v times y sub 1. V is this one. Substitute here. Y sub 1 e to the t. So we obtain minus t. If minus t. It's okay. But and the minus t or t is the same because, and the same because y is minus t is equal minus 1 times t. It's okay. The same is a linear combination. And the second, this one. It's okay. So we obtain same result. Second differential, fundamental solution of this differential equation is minus t. It's okay. Any question? So, and here using the integration, reduction of order, and then we obtain second differential, solution of our differential equation. It's okay. For example, here we don't know, and our differential equation here, this one. So solve this differential equation, homogeneous second order, but not constant coefficients. And we don't know how to solve this one. But if we have the one solution, e to the t is a solution, and it is easy to get the y sub 2. Because we don't know how to solve this differential equation, but we know and the one solution. So using this solution and using the reduction of order, because y sub 2 is equal v times y sub 1, and if we get the v, so we obtain the y sub 2. It's okay, this one. Any question? Yes, okay. And no question? I hope it is clear everything. And now let's stop here. It's okay, because in the next day we will give the non-homogeneous equation. It's okay. Non-homogeneous equation. Non-homogeneous means if right hand side is not zero. It's okay, not zero. So what can you say about the general solution of these equations? It's okay. Now let's stop here.